So when you first turn on the lathe, it's going to give you the same Haas startup menu that all the mills do, where you have to cycle the door, press power up, and then you just select cycle start or handle jog. The only difference is when you power up this machine, it's going to give you several different options as to how to power it up to make sure that it doesn't crash. Usually A is always going to be the way to go. It's going to home the X and Y axis, the B axis, the turret, or the spindle, and then the tool turret. And so if you can see right now, our turret is not in the home position and it has not been properly powered up. Once we hit A on the control panel, you'll see the X and Y axis home. You won't be able to see it from this angle, but the B axis and the spindle are homing right now. Finally, the Z axis will home, and then it will index the turret. Now we can select handle jog on the control panel, and it will let us move the machine around. This machine has an X axis, a Y axis, a Z axis, a B axis, and a C axis. The Z axis is going to move the turrets forward and away from the spindle itself, like this. The X axis is going to move at about a 45-degree angle from the ground, but in line with the center line of our spindle, like this. Our Y axis moves perpendicular to our X axis, like this. And then we can home this out to get it out of the way by hitting home G28. Now our B axis, which you currently cannot see right now, is our sub spindle, but if you just press B on the keyboard, since there isn't an option for it on the axis control buttons, and then hit handle jog again, you can see towards the bottom our sub spindle will start moving forward and backwards. This is also a programmable feature that you can use for part transfers, pulling out stock, and parting off. Once again, we can hit B and then home to retract that. And then your C axis is going to be on your spindle itself. Basically, when you do live tooling passes, and you have to indicate or you have to machine on certain sides of the parts, your C axis will orientate at the beginning of your program and then move at whatever specified angle that you need. So the next thing that we're going to go over is the chuck operation and loading stock. So this is our main chuck or our spindle. This is our sub spindle or our secondary chuck over here on the right. Both of them are operated by two yellow foot pedals on the left side of the door over here. One of them is labeled chuck, the other one is labeled sub spindle. If I press the foot pedal for the chuck, you can see the main spindle will close. If I press the same foot pedal again, the chuck will open. The sub spindle operates the same way, where if I press the foot pedal for the sub spindle, it closes, press it again, and it opens. As you can see, there's not a whole lot of range of motion for the jaws when it opens and closes, so depending on your stock size, you are oftentimes going to have to adjust where your jaws are. Each jaw has two Allen head screws on the front face of it that are used to tighten and secure it into position. There's also ridges on the bottom of the jaws and on the top of the chuck. These ridges help lock the jaws in place and are used to make sure that they are spaced evenly so that they clamp perfectly centered around your part. When you adjust them, there's a couple ways to ensure that you have them spaced properly. One of which is you can count the amount of ridges on either side of your chuck. So there's 2 or 3 here, 2 or 3 here, and make sure that the same amounts are on all 3. I can also take a scale and measure the distance from the chuck to the end of the jaw, and then make sure that each one is the same. This is the preferred and most accurate way to do this, and once we've done that, we know that our chuck has been set up properly. We can place our stock in here. You want to get it ideally gripped with all of the jaws. If you clamp a part way out here, for example, oftentimes it will not go in there straight and there will be a lot of wobble on your outer diameter there. That is not good machining practice. It's also a good way to either break a tool or have your part come loose and mess a lot of things up. So we want to make sure that we're fairly deep in the jaws here. Now when we spin it, we can see that our outer diameter here doesn't wobble very much. You can't always go by this front face here because it was cut with a bandsaw, and so if it didn't make a perfectly straight cut, which this one didn't, you'll see that if you watch the face, it does wobble a little bit, but when you look at the outer diameter, it's pretty concentric. So this lathe has 12 different tool holding positions. They're labeled on the front of the turret, 1 through 12. And each tool holding position doesn't have a designated ID, OD, or even live tooling feature. It's just dependent upon which tool holder you actually bolt to it, such as an OD tool holder, an ID tool holder. And there's some live tool holders on the other side. However, the only difference between OD, ID, and the live tooling holders is that the lives have this taper on the back side of them, and it extends into the inside of the turret so that it can mesh with the drive motor for the live tooling. Most of your ID and OD tool holders are also going to be two-directional, where you can have a tool on this side or you can have one on this side. The second side would be for machining on parts that are in the sub-spindle, but with only having 12 tool holders and potentially 24 different tools in the machine, you often have more tool offset numbers than you do actual tools. So there is a slight difference between the mills and the lathes here as well, whereas for the mills, if you wanted to call up a particular tool, you would simply go to MDI and type in T03, for example. However, since we also have to call the corresponding offset number for this tool, you have to type T03 and then 03 again, and that will call up the correct tool with the correct offsets. And tool 3 is going to be this center drill in front of us, and now I can hit turret forward or reverse, and it's going to call that tool into the active slot, which is at the kind of like 4 or 5 o'clock position on the turret. The next thing we have to do is tell the machine where this tool is. So same as the mills, the machine has no idea where your tool starts and stops, and so we have to use a probing system to tell it that. Our probe is contained right here and protected by this shield here, but if we close the door, go over to our screen, and we can hit edit, it will bring up our editor, VPS, and shape creator. We want to go up and over to our VPS screen, down to where it says probing, and then click the forward arrow. We want to probe our tool offsets, so we're going to hit forward arrow again. This is not a live tool, so it's a regular turning tool, so we're going to continue with turning tools, and we're going to do this manually. Now this is your screen for probing your offsets. If you press your F2 key, it's going to bring up your mechanisms. If you scroll all the way down to miscellaneous, hit over, and then down to the probe arm, you can hit F2 again, and then undo to get out of the screen. But you can see that our probe arm is now fully extended and ready to be used. So we'll go back to our main screen over here, scroll through the different settings. So it's got our tool number, tool 3, it's got our offset number 3. It's also got this diagram for different tool tips. So most of your like regular OD turning tools are going to be some sort of T3 or maybe a T2. T2 is usually for ID turning, at least on this machine. However, this is a center drill, and I've already got the X coordinates indicated in for this tool holder. So we only want to change the Z offsets for the length of this tool. So this is going to be a tool tip number 7, and it's only going to probe in the Z direction. Next, we need to jog our tool tip over to within, I believe the range is a 1/4 inch from our tool setter. So once we go down, once you have this row here highlighted, you can select the axis on your keyboard that you want to move in. So I'm going to type Z, and then I can press the handle jog button. It's going to allow me to move in the Z axis. I'm going to jog over. I'm going to switch to my X axis. I'm going to go back in my Z axis and get within about a 1/4 inch, a little bit more in the X. And now that my tool is next to my tool setter, I can close the door, go back to my machine. One last check that it's just going to go in the tool 7 direction, and these are my current offsets for this tool. But once I hit cycle start, it's going to tell me that damage can occur if the probe arm is down. Everything should be fine though, so we're going to hit confirm to start the cycle. And the same as the mills, where it hits the tool probe at a slightly faster pace and then goes back and touches it really gently. Does the same thing here, and now my tool 3 has had its Z offset set. There are a couple other tools that we need to set for this operation. All of the turning tools are going to be set the exact same way though, where it tells you where to jog to. It'll ask you what your tooltip direction is, and then to press cycle start. There is, however, a difference for live tooling that involves a couple extra steps. But as the screen mentioned before, we can have damage if our tool setter is down and we are performing any other operations. So we're going to jog our turret well clear of the tool probe. We're going to go back to our edit screen. It should keep us in the same tool offset category that we were in. I can press F2 again. I'm still in miscellaneous, and I can retract my probe arm. Now it's back in its original position, protected by that guard. And then I can hold my machine out to make sure that everything is going to be clear for any sort of rapid movements. I can call up the next tool that I want to probe, which is going to be tool 11. So I'm going to go to MDI T11, offset 11, rotate turret, and that's going to call in my one of my live tools that I'm going to be using, which is this 1/8 inch ball mill right here. So now we can go once again back to our edit screen. It should have already updated everything. However, it is still in the turning tool category, but I want to be in live tool. So I'm gonna go back a screen again and switch from turning tools to live tools. This is always going to be manual. This happens to be an axial tool, meaning it's pointed towards the spindle axis, or it's in line with the spindle axis. The other holder that I showed earlier, it would be a radial tool, but all we have to do is type in A, enter, and it's going to ask for a lot of dimensions of our tool here, but also the tool number, the offset number. The diameter of this is 0.125, and then It's also going to ask for the tip dimensions. We're just going to put in 0.0625, which is a 1/16 of an inch, which should be what it actually is since this is an 1/8 inch ball mill. Same thing for the Z tip dimension, 0.0625. Enter. Now it wants the same thing. We got to jog it over to our tool probe. Our tool probe, remember we put up, we got to call that back out. So we're going to extend that. And then we can move in our Z direction. Jog it here. And now this one wants it on the opposite side as if it was a tool 2. So we are going to be very careful not to hit anything. Alright, now that should be within a 1/4 inch. We can get it a little closer just to make sure. Now we close the door, and same as before, we're going to hit cycle start. It's going to give us the same warning, but this one's also going to give us another prompt. It's going to start spinning the tool at a very slow speed. It may be difficult to see from this angle, but it is rotating. And you just want to make sure that it is rotating opposite of the cutting direction because it's going to speed up as it touches, and you don't want those flutes to be attempting to cut your tool probe. So once we can confirm that it's spinning the right way, we're going to press Y on the keyboard, and it's going to continue with the tool probing operation. Now that tool has been probed. Once again, we can't raise our probe arm yet. It's too much interference, so we're going to hit handle jog Z, back this way out of the way, close our door, and then retract our tool. And that is how to probe both turning tools and live tools. So now that we've set our tool offsets, we can now set our work offsets. We don't have a work offset probing system for this machine. However, it can use its tool offsets that we've already set to determine where the work offset is in relationship to the machine. And it works using a very similar process as you would on a manual machine, where you move your tool right up next to your part. As we get closer, we want to swap to our 1/1000 speed to make sure we don't crash it. And then we're going to get very close to the part here, spinning it as we go. And right there it made contact. I'm going to back it off a little bit, and now it's just barely skimming along. So once that cutting edge, either you feel some resistance or you see a light scratch being made, that's how you know you're at your stock level, and that's where you need to set your Z offsets. So right now we're in our offsets tab. We want to scroll over to the work offsets, and then we want to highlight we're using G54, and we only have to use the Z axis because the X and Y axis are always going to be the center line of your spindle, which is going to be what your zeros for those parts on a lathe are set as anyway. So in order to change this number, all you have to do is hit Z face measure, and the number will update. Now we can slowly jog away from our parts and speed up. And once we're clear of everything, we can hit the home button. And now we are ready to load our program. So similar to the mills, you're just going to press list program. It's going to bring you usually to this screen where you can then scroll over to your USB, which is where we are running our program from. We're going to go into my folder and we are going to run this program with the center drill. Then you just click select program and then memory. We'll put it into your memory tab. You can then hit graphics, cycle start, and it's going to show what your tool paths are and how it's going to move. Basically, you just want to make sure that it's not drawing like over here, over in this direction, making sure that it's not going to crash. Because the next thing that we're going to go over is how to check and make sure you're not going to crash. Because unlike in a mill, your stock and turrets are a very rigid setup, and your tool holders and the tool turret are also a very rigid setup. And so if those come into contact with each other, it can do a lot of damage. Now that we've set our tool and work offsets and loaded up our program, watched it on the graphics, we're almost ready to start our program, but we still have a couple more things to do to ensure that we're not going to crash this machine. So normally you're only going to get into trouble when you have tools and your chuck very close together while your chuck is spinning. So one way, if you're pretty sure you have enough stock and just force a habit, or just out of force of habit, you want to check and make sure that you have plenty of clearance. I can jog my tool over to where I can comfortably say that it's not going to run a risk of crashing, and then take either a 3D printed or already machined parts, or just measure if I know the overall length of my parts. Put it right up next to my tool and see that my tool has already machined well beyond what it's going to need to for this part and is still well clear of the chuck, and I can say that that is good to go. However, if I wanted to be a little more thorough, say if I had a lot less clearance, there are a couple extra things that I would want to do. So when I run my graphics, I can see that my lowest Z tool path is this cutoff wheel right here at the very end. So what I'm going to do is I'm going to home my machine out, call up my cutoff tool, and then I'm going to go into my program. I'm going to search for my cutoff tool by typing in T0505 down, and here is my cutoff tool path. As you can see, it's going to go through a bunch of initializing, feeds and speeds, but what it actually does is it makes a bunch of repeated X movements as it slowly works its way through the parts, which is this string of code right here, which means that this Z number right above it is going to be the farthest it goes towards the spindle. So, in order to check my clearances, I'm going to go into handle jog mode and move my Z axis in. I will get closer to my part here. This one also has a Y offset. That's pretty close. And we will go in to, we'll start right here. So right now our position in reference to G54 is negative 1.21. If you look in our program, we are going to go with reference to G54 negative 1.299. So I can go one more click in. Now I have exceeded how far it is going to go in to machine this. And so I can come back to my machine, spin my chuck by hand, and realize that everything else is well clear and I don't have to worry about crashing the machine. That is usually a surefire way to tell if you have enough clearance in your parts by actually going to the offset that it's going to, or the coordinate that it's going to be machining at. But that is about the extent of what you can do before running your program to ensure that it's not going to crash. There are still some stuff you should do out of good habit and to make sure that maybe your tool offsets aren't set correctly, or there's not something weird in your code that you have to do while the program is running, but we will go over that next. So unless you're running a program that has been established and you know that you know exactly what it's going to do every time, you haven't made any changes to it for a while, you're going to want to run a program with slower rapids and also using some position readouts. So your rapid speeds are down here, and that's going to be all of your really fast non-cutting movements for the machine are going to be rapid movements. And you're going to want to slow those down so you can ensure that you're not going to crash a tool due to a bad offsets or maybe just something weird in your code. You also have this position tab where you can scroll over to distance to go. And once I start running the program, it will update these values with how far the machine is going to want to go by the time it gets to that to the end of the line of code that we're talking about. So when I go over to memory, if I press start, you can see the turret. It's going to move very fast initially, and then I'm going to set my rapid speed at 5%, and you'll be able to see the difference in speed here. So that moves very quick. But if I switch this to 5% rapid, now it's moving very slowly, and I can watch it and make sure that it's going to start cutting where I want it to, and it's not going to go too deep. Additionally, I can go back to my position tab, and you can see that these numbers have now updated. If I hit cycle start again, it's going to start moving, and those numbers are going to change with it. And I can slowly work my parts, or work my tool closer to my parts until it starts getting to the clearance plane when the coolant will turn on. From then I can press the coolant button just to turn that off, and we can get a closer view here where I will repeatedly press cycle start and then feed hold as it works in to make sure that it is not going to take too big of a cut. If I'm still not sure, right above your rapid controls is a forward, stop, and reverse button. You hit stop, the spindle will stop spinning, and you can open the door to the machine and check from another angle here to make sure that you're not cutting at, like, say, 1/2 inch deep. But this looks pretty good. Also, this program was set for a bigger stock size than we have right now, so it is going to cut air for a second, but that'll be all right. It gives us plenty of room to ensure that nothing is going to go wrong. In order to start this back up, we're going to hit cycle start and feed hold again, very in rapid succession, so that the machine has time to get your spindle up to speed before it starts cutting. You do not want to stop your feed in the middle of a cut, as it will continue spinning and the rubbing will generate a lot of heat and burn up your tool and possibly mess up your part. And it's a good way to ruin or break an insert. So do not stop it while it is in the center of a cut. But this looks like it's going to be fine. It's only going to move, it looks like a couple thou, which is what our depth of cut is set as. So we can turn our coolant back on and let it machine. It's going to make that first facing path. It's going to slow back down. it's going to start a roughing pass, but we're going to stop it with the feed hold button, turn the coolant off, and then turn the spindle off so that we can open it and make sure that everything gets faced. As you can see, we missed a little bit of material there. We know that we have plenty of clearance, so it is no problem for us to come back to our offset tab over here, go to our work offsets, and do minus 0.08, oh no, not 0.008, sorry. So we're gonna move it 1/8 thou back. That's a super small amount. It should be enough to get that stock completely faced though. If we press enter, it's going to subtract 1/8 thou from that number. Now we can go back to our memory, reset, and restart our program. We can home it out. We can turn our rapid speed back up because we know where it's going to go now. And we will go back into our program. Slow down the rapid speed. We don't have to turn it off to check it this time. I know this is very difficult to see, but right now it's starting to turn down the outer diameter, and it has made its first complete pass, which means it's gone as deep as this tool is going to go, so we can turn our rapid speeds back up. We don't have to worry about it crashing. So by pressing this optional stop button right here, it will automatically home out the machine and stop the program and the spindle and allow you to open the door at the end of a given toolpath. And so once we've done that, we can now stop it after our first toolpath where it faced and turn down the outer diameter of our parts and inspect it, make sure that it did what we thought it was going to do, nothing broke, nothing happened to it, and we can then prepare for our next tool, which is going to be a live tool, and it's going to cut the hex shape pattern in this nut here. There is a little bit of a difference between how the live tool and the regular turning tool work in terms of stopping it and being able to look at it. Your stop button on the machine is not going to stop your tool from rotating, so it won't allow you to open the door. So it's good to use the method we talked about earlier with the cutoff wheel for this tool as well. Additionally, you don't want to be cycle stop feed hold or cycle start feed holding it so much and it's just sitting there spinning, because these live tools do have a duty cycle, which is a maximum of 6,000 RPM for 2 minutes with an 8-minute cooldown afterwards, or you can run at 4,000 RPM at an unlimited time limit. So we can go ahead and hit cycle start, switch to this tool. It will orientate the spindle, which you can't really see, and now it will turn on our live tool and the coolant. And we can start the beginning of this tool path, where once again we want to turn down our rapids. You want to turn down your rapids and make sure the tool is going to start cutting where you think it's going to start cutting for every tool, especially the first time that you're running it. And this one has a very obstructed view. As you can see that our part is being held stationary, whereas the end mill is turning and rotating about. That was the roughing pass, and now it's going to do the finishing pass. and we still have our option stop on. So the machine's going to home out and then stop. Alright, and this is our completed parts. I didn't show the entire machining, but mainly because it's just a bunch of repetitive instruction. All you really have to do is make sure that you're constantly slowing your rapids down and watching your distances to go to make sure that your parts or your tools are not going to collide with anything or take too deep of a cut or what have you.